Welcome back to the 8th section of Chapter 2. In this one, we're going to be looking at solving absolute values, equations, and inequalities. That would be just like solving equations with absolute values and inequalities that we looked at earlier this chapter. We will be looking at graphing absolute value functions in the next section. So this is just equations and inequalities solving. The graphing will be on number lines, just like our inequalities were earlier. The learning targets for today: I can solve compound inequalities, and I can write and solve absolute value equations and inequalities. So for absolute value equations, these are very, very similar to solving normal equations without absolute values. However, there is one huge difference that we're going to see here. So first of all, let's look at an absolute value problem. Just absolute value of x equals 4. So we have the absolute value of something equals 4. What can we put into that absolute value to get 4? Well, 4, the absolute value of 4 equals 4. What else could we put in there? Negative 4. So here, this x inside the absolute value could either equal either 4 or it could equal negative 4. And so that is the biggest difference between absolute value equations. We will generally be getting two answers. Well, that's one of also the biggest mistakes people make, because they'll only give me one answer. At that point, I know that you're going to be wrong. So when we do have 4 or negative 4, and these numbers are the same, it's just the difference is a plus or minus, we can write it as plus or minus 4. You don't need to. And if these numbers are different, you can't do that. So let's look at another one. The absolute value of x plus 2 equals 4. Pretty much the same. We know we have the absolute value of something equals 4, so what could we plug into this absolute value to get 4? We could plug in 4 or negative 4. So x plus 2 could either equal 4 or x plus 2 can equal negative 4. From here we just solve like normal. So we'd subtract 2 over here to get x equals 2 or x equals negative 6. And so in this case, x could equal 2 or negative 6. One of the mistakes people make is they'll do it for the first one, get x equals 2, and they'll stick a plus or minus on it. No, don't be that guy. You need to split it up into 2 because it solves differently. The only time we'll get plus or minus the same number is when there's no addition or subtraction inside of the absolute value. As soon as there is, the numbers will be different. So let's look at another one. Absolute value of x plus 2 minus 3 equals 4. So up here we had the absolute value equals a number, and so we knew what had to go in there. Here we don't. So let's make it the absolute value equals a number. Let's add that 3 over to the other side. Now we have the absolute value equals 7. So what could go in that absolute value? 7 or negative 7. So x plus 2 could equal 7, or x plus 2 could equal negative 7. Solve, so we can subtract 2 over here. In this case we get x equals 5, or x equals negative 9. And so the answer, x equals 5 or negative 9. Both those answers will work. So our steps to solving absolute value equations. The first step, we want to solve for the absolute value. We want to get the absolute value equals something. Second step, split the absolute value into 2 equations, and then solve each of those equations. So one thing I want to point out, notice over here, I did not subtract 2 until I split it up. Do not add or subtract anything out of an absolute value. That is not going to end up well for you. So try this question. We have 8 times the absolute value, 3x minus 10 minus 12 equals 20. Go ahead, pause the video, try the question, and then when you're ready, push play. How do you think you did? Did you get 2 answers? If not, push pause, get 2 answers. So if you did, let's take a look at this. First step, we need to solve for the absolute value. So here's the absolute value. We have times 8, we have minus 12. Let's add 12 to get 8 times the absolute value equals 32. and divide by 8 to get the absolute value equals 4. Now we can split it up into 2. So what's inside will equal 4, or what's inside will equal negative 4. Now we can solve. Start by adding 10. So that'll get us 14, or in this case it'll get us 6. Divide by 3. X equals 14 thirds, or x equals 2. So how'd you do? Did you get 14 thirds or 2? Oh my gosh, we got a fraction. It must be wrong. No, we can get fractions. It's okay. It's just a number. So that's looking at absolute value equations. Now let's look at some absolute value inequalities. These are going to be the same, except just like with inequalities, if we multiply or divide by a negative, we do need to flip the sign still, and we'll need to graph it at the end. So, and we do have two different types of inequalities as well. We have conjunctions, and we have disjunctions. The magic word for conjunction is and that happens when we have the absolute value is less than a positive number. So we'll have, when we split it up, we'll have something and something. A disjunction, the magic, and the graph, it's where it's going inside of your 2 points. A disjunction, the magic word is or. And this is when we'll have the absolute values greater than a positive number. And this is where we have our 2 points, and then it goes away from the 2 points. So let's look at these. We have the absolute value is less than 2. So when we split this up, we'll have x minus 3 is less than 2, and x minus 3 is greater than negative 2. We switch the sign, and we switch this sign. Then we solve normally. We can add 3 to get x is less than 5, and x is greater than 1. And so we need all the numbers less than 5 and bigger than 1. So when we're looking at an equation, it's less than 5, bigger than 1, so it'll be all these numbers. We can rewrite this as one compound inequality. You can do that for ands, not for ors. Always start out with a small number, and then the arrows should always point to the left. Notice here it's pointing to the x from the 5, pointing to the x from the 5. Here it's pointing to the 1 from the x, pointing to the 1 from the x. If you have them backwards, then that would not work out. And then graph it. We have a number line. We have open circles at 1 and 5, and we shade inside. This junction, I have this one. This is a more complicated one. Ooh. We're going to solve for it. Add 7 to get 2 times absolute value x minus 5 is greater than or equal to 10. Divide by 2 to get the absolute value is greater than or equal to 5. Split it up. X minus 5 is greater than or equal to 5, or x minus 5 is less than or equal to negative 5. Again, we flip the sign, and we change the sign here. Add 5, x is greater than or equal to 10, or x is less than or equal to 0. And when we graph it, we have our number line. These will be closed circles because it's or equal to. We have one at 0 and one at 10, and then we're going to be going away from those. And so that's graphing. We just have two. We'll have an inner range, or we'll have going away from each other. A little bit more on absolute value inequalities. Always make sure that before you split it up, you have the absolute value by itself. In this case, we have negative 3 times the absolute value is less than negative 9. So you think, oh, less than. That's an and. But first thing we need is we have to get the absolute value by itself. So we divide by negative 3, which will flip the sign. The absolute value is greater than 3. And now we can split it up. It'll be x minus 1 is greater than 3, or x minus 1 is less than negative 3. Add 1 to get x is greater than 4, or x is less than negative 2. And then we can graph it. Open circles because it's just less than negative 2 and 4. And then we're going away because we want less than -2 or bigger than 4. Then a couple things to be careful for. If we have the absolute value is greater than a negative number, what do we know about absolute values? And they're always positive. What positive numbers are bigger than negative numbers? All of them. So does it matter what we put into this absolute value? No. So the answer would be all reals. And here I just have the absolute value of x. It could be something a lot more complicated than that. We have the absolute value is greater than a negative number. It does not matter what is inside of here. Whatever comes out of it will be positive. The positive number will be bigger than a negative number. All reals. If you tried to solve this out, you'd get something where it was like this, except it would be bigger than this one or less than this one, and so it would cover the whole graph. Or it means only one of them has to work. And then the same thing happens if it's less than a negative number. What positive numbers are less than negative numbers? None of them. And this also works if it's a much bigger problem on the inside. So if you get an absolute value is greater than or less than a negative number, your problem's done. You just have to figure out, is it all reals or no solution? And then one last thing, margin of error problems. These come up a couple times, and it's kind of a tricky wording type of question, but they're actually really easy. So here it tells us about margin of error. This whole top part just kind of is a description of it. Write an absolute value inequality that shows the maximum and minimum actual measure of a nail measured to be 4.4 centimeters to the nearest 0.1 centimeter. We're going to get the absolute value of x minus what it's supposed to be is less than or equal than the margin of error. Absolute value of x minus what it's supposed to be is less than or equal to the margin of error. Done. That's all you have to do there. I've seen some pretty creative answers to this type of problem in the past, but this is all that has to happen. This is an absolute value equation that shows minimum and maximum measures possible. And so that was solving absolute values. I'll see you next time for absolute value functions. And until then, happy mathing.